Hello friends. Hello friends. In continuation with the last lecture, now we'll talk about the calibration in this lecture. So calibration is actually a very essential part of the industrial measurements and its control. So it can be defined as the comparison of uh, it can be defined as the comparison of the specific values of the input and the output of an instrument with the corresponding reference standards. Means we have to just compare a specific value with the reference standard, which will be placed at the particular places, and obviously this has to be compared with the internationally accepted standard only. Then it will be accurate for the further measurements. So actually, this calibration offers the guarantee to the device or the instrument that it operates with the required accuracy, as it is mentioned earlier as well. Right, it should be the guaranteed one, and it should give us the guarantee that it is a very accurate and precise kind of the calibration. It is a result of the quantitative comparison between the known standard and the output of the measuring system measuring the same quantity. Means this is the depends upon the output of the measuring system while doing the measurements of the same quantity. If the output and the input response of the system is a linear one, then the single point calibration is sufficient. Okay, this is something like suppose this is input, and this is on the y-axis if it is output. If suppose suppose this is a input, okay, and I can put it as input, and suppose on the y-axis if it is a output, then what we can say is that the suppose the input output relationship is a linear one like this, then the only one point calibration is sufficient. So if suppose I calibrate the instrument at this point, then it will give us the uh, uh, for us a single value of the input, will be having the single value of the output. So a single point calibration is sufficient in this case. But if suppose there is a non-linearity between the input and output, if system or the system response is a non-linear one, then set of the known standard inputs uh, to be to the measuring system is entered. So we need to use the set of the standard inputs to measure to response is non-linear. Now, this process of the calibration is classified into the various standards, and let's try to. There are various calibration processes are there, and let's see the one by one. The first one is the primary calibration. What it is mean? When a device or the system is calibrated against the primary standards. Primary standards means which is internationally accepted when at the placed at the France Severasi. Okay, procedure is termed as the primary calibration. When a system or the device is calibrated against the primary standards, the procedure is termed uh, as a primary calibration. The primary standard is an extremely accurate and absolute unit certified by the national standard institutions. This is something like the primary standard is something our national laboratories take the responsibility and they calibrate our uh, the, the units or the quantities for the measurement one. So they are extremely accurate one, because because they are directly calibrated from the reference standard which is placed at the France level. Okay, in case of the one of the is mass or the length. Okay, so they are the extremely accurate at the absolute unit certified by the National Standards Institution. Absolute here is used in the sense of being independent, inherent, and not relative, but finite. After a primary calibration, device is employed as a secondary calibration. Means if we suppose calibrate our device by using the primary calibration, then that will be employed as a secondary calibrated device or the calibration device. Example: standard register or the cell set. Now, the next type is the secondary calibrations. When a primary calibration device is used for the further calibrating another device of the lesser accuracy. Okay, this is not as accurate as the primary calibration device is there. Then the procedure is done as the secondary calibration. These devices are widely used in general laboratory practices as well as in the industry because they are practical calibration sources. So these devices are widely used because those industry personnel has to calibrate their devices uh, with the devices which are calibrated in the national laboratories or the with the primary calibrated devices. Okay? And because they are the practical calibration sources. Example here: standard may be used for calibrating a voltmeter or the ammeter with a suitable circuitry. The next type is the direct calibration. Direct calibration with the known input source is in general of the same order of the accuracy as the primary calibration. Means this is the direct comparison between the primary standard and the we know that the primary calibration or standard is directly calibrated from the standard references. So the direct calibration with a known input source is in general of the same order of accuracy as the primary calibration. The calibrated devices can be used as a secondary calibration devices. For example, here the flow meter may be directly calibrated by using the primary measurements such as the weighing a certain amount of the water in a tank and recording the time taken for this quantity if the water flow through the meter. Afterwards, this flow meter may be used for the secondary calibration of the uh, other flow metering devices such as the orifice meter or the meter. Means if we have the calibrated the first devices, then that can be used for the secondary calibration mm, uh, of the any kind of the device. Now the next type is nothing but the indirect calibration. And indirect calibration is based on the equivalence of the two different devices that can be employed for measuring a certain physical quantity. Means the there is actually the indirect equivalence of the two different devices. So we'll just try to have the indirect calibration, but there is an equivalence of the two different devices. Okay, for measurement. For example, here the turbine flow meter, the requirement of the dynamic similarity between the two geometrically similar flow meters is obtained through the maintaining the equal Reynolds numbers. Okay, equal Reynolds numbers in the sense that if suppose we are having a calibrated device quantitative measurements, or it is flowing through one kind of the pipe, okay, having the some diameter d1, its viscosity is rho1 or density is rho1 and flowing with the velocity v1, having its coefficient of viscosity as a mu1. Then similarly the other corresponding physical quantities for the unknown things will be flowing through the other path having the different dimensions, and they are utilized for the uh, measurement or the calibration purposes. Okay, so, and here the substitutes 1 and 2 refer to the standard. This is for the standard references, and this is for the which is has to be calibrated, and the meter to be calibrated respectively on the right hand side. The second substitute, right? It is possible to predict the performance of one meter on the basis of an experimental study of the another. We can try to study the performance of that meter by using the experimental study of the another one. Now, the last type or the of this calibration is nothing but the routine calibration. Routine calibration is the process of the periodically checking or the inspecting the accuracy and the proper functioning of an instrument with the standards. Means the whenever we just try to reopen the things or the start the device, then we must inspect the uh, device with some accuracy, or try to calibrate them before we start using it for the particular measurements. So this is the routine calibration, we call it as. Okay, periodically checking whenever we or think of that whenever there is some discrepancy observed by just daily users, then that comes under the routine calibration. So the entire process is normally laid down for making the various adjustments, like checking the scale readings, etc., which conforms to be accepted norms. So what are the steps to be taken in this type of the calibration process? Is nothing but the visual inspection of the instruments. Just try to look at the visually at the device, whether there is any kind of the discrepancy we can see in on the instrument, or else the checking the proper installation with the SOP, or just try to follow the SOP while trying to utilize for the next iteration or the step of the measurement. Okay, proper installation of this. The zero setting of the all the indicators means the pointer has to be at the zero, or else if the system is just started and no input is applied, then it should give us the zero reading. So zero setting of the all indicators, and level of the devices which require the precautions. So the precautionary measures has to be followed while measurements, and then we can have the recommended operational test to detect the defects present in the device. So that has to be considered here, the recommended operational test to detect the defects. Thank you.